Now we'll talk about the physical layer. All right, physical layer. Physical layer, all the cool kids just put PHY. I've been doing that too. So PHY, I'll make that P look a little better. This is the physical layer. And as we said before, this is bit by bit transmission. Okay, I want to get one bit across a cable. All right, the standards here say just a couple of different things. One thing is that what media you are going to choose. This is the media that you're actually using to transmit your information in. Some of the media we will talk about are fiber. So fiber optic cables. We will talk about copper wires. So we send electricity. Fiber is about light. Copper wires, and then wireless. So even though you can't see a wireless connection, it's still a physical layer connection. So standards are media. Standards have to do with the connectors. Okay, and we'll look at some connectors as we go on. And the third thing that standards generally do, there are a lot more, is the length. This is how far between devices. So length is an important thing at the physical layer. And we'll get into that right now, because we are just that excited. All right, now we're going to talk just in a point-to-point situation. Yeah. So I told you about my back thing, right? It was from leaning always to the left and never moving, and this chair won't allow me to move to the right very well. All right, I got a point-to-point situation here. I have a PC. Okay, this is my host. I'm going to, though, this time connect it directly to the other host. All right? So I have one physical cable running between the two. Okay? This is probably a copper cable, and for the most part we'll deal with copper, but we'll just say it's copper for now. Now, when I want to send a 1 or a 0, I need to send a signal. A signal is a disturbance that propagates through the medium. All right? So my signal here is going to be some sort of disturbance that is going to move through this medium. I want to emphasize that. In telecommunications, signals move through the medium. It's not that the instant I send something here, it immediately appears over here. Okay? That would defy the laws of physics. Although there are things with, we're not going to get into it. Never mind. Forget I brought that one up. It just doesn't. So it propagates through the medium. Now, let's think about propagation. I'm just going to draw a tiny little diagram over here. Let's say I built a little fire over here. Here's my fire with my sticks in it. And it's smoking, right? Okay. If I put a blanket over the fire, I'm going to concentrate the smoke. And then if I pull the blanket off, I'll have a very concentrated bit of smoke. And I might have another one here. Okay? So the signal here is the disturbance. So the disturbance is this, gathering of the smoke, and then I release the smoke, that's the disturbance, and it goes through the air. That's the medium. Okay? Now things happen to my puff of smoke along the way. As it gets higher up in the sky, what happens to my puff of smoke? It sort of dissipates, right? It kind of spreads out, okay? The spreading out and everything else, these are called propagation effects. Okay? So as the disturbance goes through whatever medium we're using, stuff happens to it. Okay? Now, what I try to send from out of my computer, if this is a copper cable, I'm going to send very distinct changes in voltage. Okay? And it's going to go through a circuit, and I'm not showing it, but there's actually 2 wires here. A circuit has to require, it's a loop, it has to have 2 wires. We'll talk about that in a little bit. So there's got to be 2 wires here, but anyway. So, very distinct changes in voltages. Now, I'm sure you all remember what makes electricity. Like, how does electricity get conducted through a wire? See, that's my joke is, like, you weren't paying attention in 5th grade, were you? What this is electrons are traveling from atom to atom as it goes through this copper. And one of the cool things about copper is it loves to give away its electrons, so it shoots out its electrons. Now, there's 2 things that are going to happen along the way. Eventually, and I'll just show you, the signal when it gets over here is going to be, just like our smoke signal, kind of dissipated. Okay? One problem is what we call attenuation. Some of the signal is just lost. Okay? This would be when it's received, or some of the electrons are just lost. This is a weakening of the signal. Okay? So it was really high here. By the time it gets to the end, it's not as high. So what happens is, and I'm sure you all remember this, some of the electrons go through, and sometimes the copper atom doesn't want to give the electron away. Okay? And it holds on to one of the electrons, it just keeps it. If it holds on to it, you guys know where does that energy go? So the electrons were wanting to move, and then the electron gets held onto. No, it's heat. Anyway, it ends up being released as heat. So one of the reasons you don't put too much, or you have a thicker wire, is if you have, a lot of this resistance, the wire will heat up and eventually start a big old fire. That's why you have fires in your house. Don't plug too many things into your power strip. That's why it has a circuit breaker too. Anyway, so attenuation, weakening of the signal. So the energy that's lost as heat means our signal is not as strong. There's not as many electrons making it all the way. The other effect is distortion. Distortion is the flattening out, or what am I calling it here? Dissipation? I always have a good word for this. Oh, I just have changing. Okay. Well, anyway, it dissipates. What happens is some parts of the signal arrive early and some arrive late. So we'll just say some parts of signal travel faster. Okay? So there's some electrons that get to the end really fast, a whole bunch that, they don't get there quite as fast as they could, and then there's some that are kind of late. So that causes distortion. Now, if this is too much, can you tell if it's a 1 or a 0? I need to be able to, at the destination, be able to tell 1 versus 0. If I can't, then I got problems. I'm not going to get any information across my line. So, attenuation, again, is weakening of the signal. Distortion is this flattening out of the signal. And the bottom line is it may not get all the way through.